Good morning to all of you. So this is video lecture number 4, and in this video we discussed about Newton's second law of motion. What is the vector form? What is linear momentum? Change in linear momentum. So open your notebook and write the first heading of this video. That is Newton's second law of motion. Newton's second law of motion. Okay. So what is the definition? So first of all, write the definition. The rate of change of linear momentum is directly proportional to the, the rate of change of linear momentum directly proportional to the external force applied on the body. Okay, so this is the statement for the Newton's second law of motion. Now, in mathematical point of view, what is linear momentum? Change in linear momentum. So you can see we all know that P equal to mass into velocity. Or first we can define the mathematical notation of second form. So it is written F external force is directly depend upon change in momentum. So it is written delta P upon delta T. So F external, and we all know that force is a vector quantity and momentum is also a vector quantity. So F external, in place of proportionality, if we put equal sign, then we have to add constant term, that is k. So k delta p upon delta t. What is change in linear momentum? That is final momentum minus initial momentum. So k, we get p final minus p initial upon delta t. So F external equal to k P final. P final is mass into final velocity minus mass into initial velocity upon delta t. So we can write K m v minus u upon delta t. So v minus u equal to, what is v minus u? That upon t, that is equal to small a, acceleration. So we can write F external equal to k into m into a, and experimentally it is found that k equal to 1. So what is the formula for F external? That is F external equal to m into a vector. Okay, so this is the statement for the second law, and with the help of formula we derive that F external equal to mass into acceleration. Okay, so F equal to ma. Now what is the dimension and unit of force? So one by one I explain all the things. You should know that first line is F external is proportional to delta P upon delta T. F external equal to K into delta P upon delta T. Delta P is what? Change in linear momentum. Change in linear momentum, and we all know that the change in linear momentum is what? Final momentum minus initial momentum. So P final minus P initial. So F external equal to K final momentum mass into final velocity minus mass into initial velocity. So we get mv minus mu upon T. Okay. So m v minus u upon t, v minus u upon t is what? Delta A. V minus u upon delta t is what? Acceleration. So we get F external equal to k into m. Now what is the unit and dimension? So right next heading, that is unit for force. So with the help of formula we can write F equal to mass into acceleration. So SI unit is what? Kg. Acceleration unit is meter per second square. Or the name of scientist, that is Newton. We can simply write capital N. Okay. Now CGS unit in kg, that is gram in CGS unit, and length is centimeter per second square, or scientist name dyne. So what is the relation between Newton and dyne? So 1 Newton equal to 10 raised to power 5 dyne. From where it comes? See, 1 Newton equal to 10 raised to power 5 dyne. Sometimes it is asking prove that 1 Newton equal to 10 raised to power 5 dyne. So we know that 1 Newton is the value for force if 1 kg mass. So F equal to 1 Newton when 1 kg produces 1 meter per second square acceleration. So if we change kg into gram, so that means 10 cube gram, and meter into centimeter, so 10 square centimeter per second square. So we get 10 raised to power 5 gram centimeter per second square. So 10 raised to power 5 dyne. So 1 Newton equal to 10 raised to power 5 dyne. Okay, clear? Sometimes it is generate note 1 kg weight or 1 kg. So if 1 kgf is given, so you write 1 kgf equal to 1 kilogram force is equal to 9.8 Newton. 1 kgf equal to 9.8 Newton. When small g is in given 9.8 meter per second square. And in the same way, 1 gf, 1 gram force, it is equal to 980 dyne. 1 gram force equal to 980 dyne. Okay, so 1 gram force is clear. 1 gram force equal to 980 dyne. What is the dimension for force? So dimension, we all know F equal to ma. So what is the dimension for mass? That is capital M. And what is the dimension for acceleration? That is LT minus. So the dimension for force is M LT minus. Okay, so dimension is clear. Dimension equal to MLT minus 2. Okay, this point is clear or not? Tell me. So dimension is MLT minus 2. Now the force is clear. Linear momentum, change in linear momentum, rate of linear momentum, all things are clear. So in this video, we discussed about force, change in momentum. Now one more thing, that is second law in vector form. So write the heading, second law in vector form. So we all know that F external equal to delta P upon delta T. This is the representation of Newton's second law in vector form. F external equal to delta P upon delta T, and if we are talking about very small time, so we can write dP upon dt, where d is the small change in linear momentum. Delta is the change in linear momentum and dP is the small change in linear momentum. Okay, so all the things are clear to all of you. Okay, students, bye bye. Take care, all of you.